Think about this for a second. An AI that could manage a project with millions of steps, like, say, building an entire skyscraper or running a national supply chain, and do it with absolutely zero mistakes. Sounds like something straight out of a sci-fi movie, doesn't it? Well, what we're going to talk about today is a brand new approach that makes this a real possibility. And trust me, it's going to challenge everything you think you know about how we should be building AI. So if we have these super smart AIs, why can't we just do this already? What's the big holdup? Well, the fundamental problem, is that even our very best AI models have a tiny, tiny error rate. And look, for one single task, that's not a big deal at all. But when you start stringing together thousands or even millions of tasks, that tiny error rate turns into a giant project-killing monster. Yep, this is where the domino effect just completely takes over. You could have an AI with a 99% accuracy rate. And that sounds amazing, right? I mean, 99%. But that 1% chance of failure, well, it's there at every single step. And over a long enough project, it pretty much guarantees failure. It's not a question of if it's going to fail, but when. And this chart, wow, this really just spells it out, doesn't it? Even with that awesome-sounding 99% success rate per step, look what happens. After just 100 steps, your odds of a perfect run have already dropped to 37%. And at 1,000 steps, you're at less than 0.01%. It's basically game over. This is the core reason why getting AI to do long, complex tasks is so incredibly hard. Okay, so how do we fix this? Right now, there are kind of two main schools of thought. The first one is what you could call the brute force path. Just keep building bigger, more powerful, smarter models and just hope that error rate gets to zero. But the research we're diving into today, it takes a completely different path, a much more clever and I think elegant path, building smarter systems out of smaller, simpler parts. And here's the big idea. It's called Massively Decomposed Agentic Processes, or MDAPs for short. I know, it's a mouthful, but the concept behind it is actually beautiful in its simplicity. Instead of throwing one giant AI at a giant problem, you smash the problem into a million tiny, microscopic pieces. Then, you give each tiny piece to a small, specialized AI agent to solve. This whole approach is built into a system they call Maker, and it runs on three really simple rules. First, you decompose the problem into the smallest possible steps you can imagine. Second, and this is the key, you have a bunch of AI agents solve each tiny step, and then they all vote on the right answer. And third, you automatically red flag and just toss out any answers that look weird or badly formatted. It's like a quality control check at every single stage. So what's so special about this voting system? Why does it work so well? Well, it all comes down to basic statistics. See, by having multiple independent agents all work on the exact same tiny problem, you can easily spot and filter out the random one-off mistakes that any single agent is bound to make sometimes. It's basically crowdsourcing the truth for every little decision. And here, you can see exactly why it works. For any one little task, the correct answer is just way, way more likely than any single wrong answer. So yeah, a couple of agents might make a mistake, but they're very unlikely to make the exact same mistake. The correct answer gets the overwhelming majority of votes, and the system moves on with a super high degree of confidence. Okay, so the theory is solid. Decompose, vote, red flag. It sounds great, but does this radical new idea actually work in the real world? Can a system like this really handle a problem with over 1 million steps and actually deliver on that promise of zero errors? To really put this thing to the test, the researchers picked a classic computer science puzzle, the Towers of Hanoi. Now, with 20 disks, solving this puzzle requires, well, that number, 1,048,575 individual moves. It is the perfect test for this, because if you make just one single mistake, the whole solution fails. Period. And the results, they are absolutely staggering. I'm just going to read this to you straight from the research paper. They say, Maker is the first system that successfully solves a task with over 1 million LLM steps with zero errors. Let that just sink in for a second. Over 1 million steps, not one error. It's a monumental achievement. But here's the part that really made my jaw drop. The big surprise. You would think to pull something like this off, you'd need the biggest, baddest, most expensive AI model on the planet, right? Well, it turns out You don't. In fact, using a smaller, less powerful model is actually better. Just take a look at this table. It shows that the most cost-effective model for the job wasn't the one with the absolute lowest error rate, and it wasn't the cheapest one either. It was a smaller model, GPT 4.1 Mini, that hit the sweet spot, the perfect balance between its cost and its reliability. And that is the real magic of this system. You can use cheaper, more efficient models to build something way more reliable than one single, giant, expensive model. And this is where it all clicks. This isn't just some weird AI trick. It's a fundamental principle of great engineering. In software development, we went through this exact same revolution. We moved away from huge, clunky, monolithic applications to these flexible, resilient systems called microservices. That's exactly what's happening here. This is the microservices revolution, but for AI. So why does this matter so much? Well, the implications are just huge. We're talking about a future where we can build incredibly safe, incredibly reliable AI systems for things that really matter, like medicine or finance or critical infrastructure. We can do it for way cheaper by using these smaller models. And we get this amazing ability to audit and control the process at every tiny step. It's a completely new path forward, a smarter, safer, and way more efficient path towards superintelligence. So I'll leave you with this question. For years, the race in AI has been all about building one single, giant, all-knowing brain. But maybe we've been looking in the wrong direction the whole time. Maybe the future of intelligence isn't one big brain at all, but millions of tiny minds all working together in perfect harmony. It's a radical thought, but it might just be the key to finally unlocking AI's true potential.